two forces, P and Q, are acting on a screw. Find the resultant acting on the screw. When I tell you to find the resultant, okay, when I tell you to do that, I mean you need to find R, but also the angle. Okay, that's what I'm asking you when I tell you to find the resultant. Okay, so basically the point where the forces are acting is the point A, which is the actual screw, okay? So I truly suggest that in the point where the forces are acting, you place your Cartesian plane, just like I'm doing right now, okay? Now I want you to take a look to this. I'm going to put my Cartesian plane right there when my forces are applied. Okay, better like that. So, as you can see, now I have my forces applied on the screw, but my forces are actually placed in a Cartesian plane. Now, as a reminder, I know that in your math class from other years, like for example last year, you should have learned that a Cartesian plane it's divided into quadrants. Okay, you have here your first quadrant. This is your second quadrant. This is the third quadrant, and this is the fourth quadrant. The reason why we care about the quadrants is because of the signs. For example, in the first quadrant, we have these signs, positive, positive. In the second quadrant, we have these signs, negative, positive. In the third quadrant, we have these other signs that are negative, negative. And in the fourth quadrant, we have these signs that are positive, and negative. Why am I telling you this right now? The reason is because I want you to get used to work with Cartesian plane. Remember, in the Cartesian plane, you have your y-axis and your x-axis. So there's nothing more to add over there, okay? And from this, I want you to identify the quadrant where you are working with. For example, here, my two vectors are applied in the first quadrant. That's the analysis that I want you to make. Now, another thing that I want to review is the signs. In the Cartesian plane, the first sign refers to x, and the second sign refers to y. Remember, x, comma, y, x, comma, y, and x, comma, y. Which means that the first sign always corresponds to x, and the second sign always corresponds to the y-axis. And just for me to know if you actually getting this, help me by telling me there. In the vector I just draw, my y component is going to be positive or negative. In the vector I just draw, this one right here, my y component, sorry, it's going to be
positive.
It's going to be positive or negative, the y component.
Negative.
Take a look. My y component, refers to the axis, to the y-axis. As you can see, the y-axis over there is in the negative side. Also, if you don't want to memorize like that, you can tell that in the fourth quadrant, the y is negative. There are many ways to see that. Another way to see it is that my arrow is going down. It's going to the right, but also it's going down. So there are many ways to, well, there are many ways to tell if the sign of my component is going to be positive or negative. Now, another thing that I want to show you is that this kind of exercise is done almost in the same way as I explained you last week. So in the vector column, what I'm going to place is the vectors. So here, I'm going to draw my two vectors. Okay. I have my vector P and I have my vector Q. Okay. And I'm going to put all the information I consider that is useful. For example, here is P, which is 40 Newton. Sorry, this one is Q. And this one is P, which is 40 Newton. I also need to include information about the angle. The angle tells me how open or closed a vector is. So what I do is I trace a dashed line to represent my x-axis in both vectors. Now this dashed line that I just did represents from where I am measuring my angle. So as you can see right here, my angle of 20 is measured from the x-axis. And this angle right here is also measured from the x-axis. Okay? So in other words, this dashed line is telling me that my angle here is according to the x-axis. Okay, so tell me, what is the angle that I have in the vector P?
20 degrees.
In my vector P, I have an angle of 20 degrees. My vector Q, what's the angle in my vector Q?
25.
Okay, 25 degrees. Who else agrees that it's 25? Okay, so let me tell you another sad story. In this exercise, the 25 is a common mistake for most of my students. Take a look. My angle of 25 is measured just in one portion, okay? It's not all. Take a look right here. My angle of 25 is only measured between the vectors, okay? And you don't measure the angles like that. You are measuring the angle from the x-axis. That's the right way to measure the angle. Now, one way to do that is mentally getting rid of the vector that is in between, okay? If you get rid of the vector, what's the angle that you have in total? If you get rid of the vector in between, you will notice that you have two angles together. You have the angle of 25, but also the angle of 20. That is exactly what I want you to see. My angle is always measured from the axis, okay? So you have to measure all the opening of the angle. Now let's take a look. Another way to see it is by using a protractor. Let me bring it. If I put a protractor right here, bueno, no se mira, ¿verdad? No se mira. No. Okay, you don't see it. So I'm going to put my protractor over there. I'm going to put this apart just for this moment, okay? And I want you to see something. I'm going to draw again the vector Q. And I'm going to draw it from here, okay? So I did it again. I did my vector Q again, and I'm going to place it in my protractor. Almost. No, I can't. I'm sorry. I'm going to put it in my protractor right there from the okay, from the center of it. It's not in the center. I cannot place it. Sorry. There's no way I can place it. Let me see if I can make it. So unlucky. Okay. Now I did it. Sorry. Problemas técnicos. Thank you for understanding. Now take a look. I place my vector exactly from the center in my protractor. And tell me, what is the angle that you see in the protractor? Is it 25 or is it 45?
It's 45.
It's closer to 45. Okay, I know that here it says that it's 46, but remember it's not totally well placed. I cannot move it exactly in the place I want to. But the idea of using a protractor is very, very useful in physics, okay? The protractor tells you that this angle, it confirms that this angle cannot be 25. So by the size of the vector and the distance from the x-axis, you can tell that is an angle that is greater than 25, and when you measure it, you realize that is true. It's more than 25, precisely 45 degrees. So be careful when I give you this kind of exercises, because I'm not always going to give you the exact values that you need to get your procedure done. So sometimes you have to do an extra work. Okay? So let's take a look at this exercise. Right now, I have to do a correction in the vector Q because my angle is not 25, is 45. And that mistake, let me introduce you the mistake that the reason number 2 why people flunk in physics. So one way to do it is to get your vector and separate the two angles. Okay, 20 and 25 actually makes an angle of 45 degrees. If you want to do it like that, for me it's perfect, okay? As long as you do a process. Both ways are going to be just fine. So, after I do this, I get my components, okay? So for my components, I always use two colors. One color for X, okay? And one color for Y. Even if I'm not using ruler here, you see it's organized. Now, let me ask you something. How is the side PY according to my angle? Is it adjacent or is it opposite? How is
Opposite.
it is opposite. So you say go to the y component and write PY is opposite to my angle. So, sorry, what is the trigonometric function that I have to use for opposite? What is a trigonometric function? Sine or cosine? The one that we use for opposite. No participation today? You want us to do a special quiz today for no participations? Which one are we going to use for opposite? So or ka?
Ka.
Okay, let me see. So you're saying that cosine is equal to adjacent over the hypotenuse. In Ka, I don't see any opposite side. But in So, I have the definition that is sine is equal to opposite over hypotenuse. Opposite is only used in the trigonometric function sine. So, sine. So when you have involved, your opposite side is always sine. Opposite, sine, always. I'm not saying y sine. I'm saying opposite, sine, always. So your opposite side is calculated by using the trigonometric function sine. So Py is going to be equal to 40 Newton times sine of the angle, which is 20 degrees. How much is this? How much is this?
13.68.
Okay. Now, I want you to analyze something else. Xavier?
No, I made a fail, sorry.
Okay, don't worry. So I want you to analyze something. My vector P is located in the first quadrant. So my signs of my components are going to be positive and positive. Take a look. This is related to math. So you have your vector, which is located in the first quadrant. Okay? So what are the signs that you are going to write in the components? The signs are given in the quadrant. It's going to be positive for x and positive for y. That is another way to write the signs of the vectors, okay? So you put the positive over there, and you can write that also the arrow. That's for the y component. Therefore, the x component is going to be the other trigonometric function. So px is going to be adjacent, and it's going to be using cosine. So you say Px equals 40 Newton times cosine of the angle 20 degrees. How much is Px?
37.58.
37.58 Newton. Again, I repeat, because my vector is placed in the first quadrant, my x component is going to be positive. Or you can just say that it's going to the right, therefore it's going to be positive. In any way, it's going to be the same. Now, tell me, QY. How is QY according to my angle of 45? Is it opposite or is it adjacent? QY is opposite or is it adjacent to my angle?
Opposite.
It is opposite, therefore you're gonna be using sine. So you say QY is going to be equal to 60 Newton times the sine of the angle, which is 45. How much is QY?
$42.42.
How much?
42.42.
Okay, positive or negative?
It's positive and it's 42, miss.
42.42.
Okay, it's going to be positive and it's 42.42, so it's going up. Remember, again, I repeat, you analyze your vector. You say, okay, my vector is again located in the first quadrant, so my two components are going to be positive. So I'm going to write now the sign of my other component, and I will get it. Qx therefore is going to be the adjacent side, therefore I'm going to be using cosine. If you see, I analyze only the side that is opposite, because in my opinion it's easier to see the opposite side. Now Qx is going to be equal to 60 Newton times cosine of 20. How much is this?
56.38.
And because it's positive, it's going to the right. Now what we do is we add the x and the y components individually. How much do you get in the x? How much do you get in the x?
93.96.
How much do you get in the y?
56.1.
60.1.
Okay. Now what we do is we apply the formula for the resultant. So we say square root of 93.96 Newton to the second power plus 56.1 Newton to the second power. How much do you get? Guys,
11,975.69.
sorry, I have a mistake. I didn't notice. I have a mistake right here. The angle is not 20. The angle is 45. I'm sorry. Did you notice? I did a correction right here. My angle is not 20, it's 45. Therefore, this answer changes. I'm gonna make a correction over here. I have a 42.42 Newton as an answer. The reason is because I have this, okay? I have this. Take a look. I just did a box. This is a square, of course, okay? And an angle of 45 and I can have right there represents the half, exactly the half of a 90 degrees angle. Remember that you have in a square, you have 90 degrees angle in each side. So by having an angle of 45 and 45 right there, tells you that your vector comes in the middle, okay? And also tells you that your sides 1 and 2 are going to be equal. So, because here I have 4 boxes, my side measures 4 and 4. This tells you that anytime you have an angle of 45 degrees, the two sides are going to be equal. Now, let's make a correction here. How much do you get in the x-axis?
80.
80. Okay. Now here in the resultant, the other one is correct. In the resultant, how much do you get? 80 to the second power plus 56.1 to the second power. How much does it give you?
9,547.21.
Now when you get the square root of this, gives you how much?
Ninety 97.7.
These are newtons. And when you get the angle, you say angle is equal to arctangent of y goes up 56.1 newtons divided by 80 newtons. You cancel newtons with newtons. How much does this give you?
35.04.
35.04 degrees. With this, you finish your exercise. Now, what I want to show you is something else. Remember that I say, always opposite is going to be sine. I'm not saying always y is sine. I know that you are smart enough to analyze that in the y component we have been using sine all this time, but it's not always going to be like that. So when is going to be different? Let me show you another example here. A very nice example, because I don't want you to commit this kind of mistakes, okay? So I'm showing you a Cartesian plane right here. Okay, I'm going to zoom in because I just want you to focus on this. Okay, now imagine, no, do not imagine, I'm going to draw it, okay? So I have a vector over here, okay? And I'm telling you that that is an angle of 30 degrees. And then I say, guys, how are going to be my components? For example, my x component, let's say that this vector is called A, okay? So my component AX, how is according to the angle? Opposite or adjacent?
Opposite.
So what trigonometric function are you gonna use? Sine or cosine? Sine or cosine for opposite?
Sine.
Sine. This is what I want you to see. That not always x is cosine, not always y is sine. We care about the position of the angle. The angle there tells you that the opposite side is not the y component, is actually x. So we